Today what we're going to look at is a couple transformations. We're not going to do all the transformations in one day. Today we're going to specifically look at translations, which is a kind of transformation. And it's just when the graph moves left, right, up, or down, but the actual shape of it does not change. So there's no vertical stretch, compress, all that good stuff. Okay. The paragraph up top says, so far in this course, all the different forms of quadratic functions. Yeah, this is in the book. Sorry, the book pages. All right, we've looked at all the different functions. Then you've got the parent function, which is what we're going to look at first, which is just x squared. This is the most basic quadratic function with your vertex starting at 0, 0. It says the pattern of this function is that for every x value, the output is x squared. So all that means is to find this y value, we're just going to square the x value. So 0 squared is what? 1 squared is what? 2 squared? And then I will normally, for this, because most times you can get another point on there, 3 squared is what? 9. So you would take those points, go ahead and graph them. You need to know those 4 points that are in that table. Because if you remember, and don't write this down, this is just going back to absolute value. Whenever you had this table, and on the outsides I had you write the points of the parent function. And then maybe we would go in and all the x's we would multiply by 2 and subtract 1. Maybe the y's we would add 4. These are the points that you would put on the outsides of that table before you applied the transformations to. So you need to make sure that you know those right there. Whenever you're graphing this, you'll graph one side of it like we already have. After that, you're going to use the axis of symmetry to graph the rest of it. So you're just going to reflect the points across. And then you'll have your parabola. And that's what B is saying down there. That's what B is telling us to do. Is to graph the points that reflect across that x-axis. All right, go ahead and flip over to the next page. A lot of this right here is just going to be some vocabulary. Okay, so it says you just analyze the basic form of the quadratic function, okay, which was just graphing x squared. For a quadratic function, if you know the vertex and any 2 points to the right of the vertex, you can use the axis symmetry to identify the other half, which is what we just did. A set of key points that help identify the basic form of any function is called the reference points. So the ones that we did off to the right, that's what we're going to call the reference points. And again, there they are in that table. It says, now that you understand the structure of the basic quadratic function, let's explore how to apply transformations to the graph of new functions. Recall that a transformation is the mapping or movement of all points of a figure in a plane according to a common operation. Translations, reflections, dilations are examples of transformations. That's just a very wordy way of saying, hey, the graph is moving around the coordinates. Okay? You have what is considered a rigid motion. Okay, and that is just the it's a certain kind of transformation as well. It's where the shape, the size and the shape, again, do not move. What those are going to be let me clear that out to give me more room here. So one of those is going to be translations, which is the main thing we're going to look at today. Which we've talked about these before. If it is plus C, which direction is that going to move? Left. If it is minus C, which direction is that? Right. Thank you. Plus D.
Up.
Minus D.
Down.
The next one is a reflection. And that is just going to be that negative A value that gives you a reflection. And then also a rotation, which is just the negative B value. Okay, we're going to skip that next part down there. It's just something that gets a little wordy that I think probably makes it more complicated than it has to be. Okay. Coming down here, this is comparing what is the vertex form to what is kind of the transformational form. So if you look at this, what I have up here in the red box, that is the vertex form. What I have highlighted is the transformational form. Okay, and it's kind of what we've looked at. Question 3 says, how are the H and K values of the vertex form represented in the transformational form? So the H value is the same as what? Someone's about to say it over there. Okay, it's going to give me the axis of symmetry. But what letter over here is it the same as? C. So the H, that's the same as C. The K value is the same as what? D. Alright, so guys, they're doing the exact same thing. It's just that this vertex form, a lot of times it's used whenever you have a graph that has some kind of vertex. Quadratic, absolute value, those are the main ones. Alright, so let's go to the next page. So this is another part that gets a little wordy. I'm just going to kind of explain to you the gist of this. So you've got the parent function, and it's asking us to apply these two transformations to it. Which, that minus 4 is going to move it which direction? Right 4. And then the plus 2 is going to move it which direction? Up 2. So right 4, up 2. So if I move it to the right 4, I'm going to take each point, and I'm going to add 4 to the x values, okay? And then I'm going to add 2. So if you look at this first graph, all they've done on this first graph is that they moved the vertex right 4 up 2. Let me find a darker color. Alright, let me get a darker color so y'all can see this here. So looking up here, again, the first thing they've done is they've just moved the vertex, okay, right 4 up 2. Over here, they've then taken every point, so this has gone right 4 up 2. They take each individual point, and they're moving them all right 4 up 2 to get this right here. Okay, the reason why they kind of point this out, or why I think it might be important, is I've had some students in the past, well, they just think the transformation, for some reason, only applies to the vertex, and then they don't know what to do with the rest of the parabola. Okay, so you need to make sure that every individual point you're moving right 4 up 2. So if you go to the next page, so we'll write this in. So again, if I'm going to the right 4, I need to take each x value and add 4 to it. It's going up 2. So I'm going to take each y value and I'm going to add 2 to them to get these resulting points. Now, guys, the way they have this written here, and I don't care which way you do it, this is the same as kind of what I was showing you at the beginning, where you've got your parent function points out here. You would add forward all the x values, add 2 to all the y values to get your new points. Okay, this is the way we did it whenever we were talking absolute value. This is set up just a little different, but you can do whichever way you want. So, looking at that table, where 0, 0 was my original graph, am I always going to get my vertex from the point that came from 0, 0? Yes or no? So this means yes right here, this means no. What do you think, Meredith? Yes. Okay, your new vertex is always going to come from that 0, 0 point. So you've got to make sure that you know what that new axis of symmetry is. Okay, from the parent function it was this x value. Your new axis of symmetry is going to be this x value. Alright, so whenever it says why is it important to establish that new axis of symmetry, so that you can reflect the new points across it. So that you can reflect the new points across the axis of symmetry. So now we've got a new transformation here. So we're taking x squared, we're applying this transformation to it. So what am I going to, which direction does this go? Right 2. So I'm going to take each x value and do what to them? I'm going to add 2. What am I going to do to each y value? Nothing. Leave them alone. So now going down to these graphs, it's a very step-by-step process of how it's showing you how to graph the parabola. So the first thing I'm going to do is I'm going to graph those reference points right there. 2, 0, 3, 1, 4, 4. The points that we just wrote in that table up there. The next step that you would do, so we've got these points right there, is to put the axis of symmetry on your new vertex. So it's going to go right through the new vertex of 2, 0. Which means that my axis of symmetry is x equals 2. And then again, once you have that, you're going to reflect the points that you have across that. And draw your nice, neat parabola. Once you have that, go to the next page. So we've got another one here. The +2, which direction is that going to move the graph? Left 2. Which direction is the minus 3 down. So I'm going to take each x value and do what to it? I'm going to subtract 2. I'm going to take each y value and do what to it? Subtract 3. So my x's, I've got negative 2, negative 1, 0. And I've got negative 3, negative 2, 1. And go ahead and start graphing that the way that it showed you. You graph those 3 reference points. Put your axis of symmetry through the vertex. And then graph the points that reflect across the axis of symmetry. Now, for those of you who are very picky and want as neat of a graph as you can get, which I don't blame you, remember the pattern of how this works. We kind of talked about at the beginning. If I go to the right one and look down there by my vertex, 1 squared is 1, so I went up 1. If I go to the right 2, 2 squared is 4, so I would go up 4. So from the vertex, if I go to the right 3, how many units up would I go from there? What? 9, because 3 squared is 9. And guys, that right there, that pattern is how the parabola gets its shape. So I could actually put another point up there at 1, 6, and I would get the point that reflects across the axis of symmetry. Okay, let's go down here. Now, we're going to write these equations in reference to the parent function, which I'm just going to put up here just with the red dots. Okay, so the first one we're going to do is we're going to write m of x, which is this one. But we're going to write it in terms of f of x. Okay, so what that means is I'm going to write m of x equals taking f of x, and then I apply the transformations in there. Okay, so going from the parent function to m of x, did it move to the right or to the left? How many? Think vertex to vertex. 5. So is that going to be plus 5 or minus 5?
Minus 5.
And then did it go up or down? How many? So that would be what in the equation? Plus 1. Next, the same idea, but I'm going to p of x. So I will take f of x, and I'll apply the transformations going from the parent function to p of x. Okay, so did it move to the left or to the right? Left, so that would be what? Did it move up or down? No, so that's it. Whenever you're writing it like that, in that transformational form, you don't have to have the squared on it. Okay? Having this f of x, referring back to f of x, tells us that it's quadratic. Alright, so on C and D, this is disregarding the parent function, and now we're going from the one of the parabolas to the other parabola. All right, it's the same idea, but this is just a very SAT, ACT type question, as opposed to just going from the parent function every time. So you would write, so we're writing P of x in terms of M of x. So I'm going from, that tells me that I'm going from M of x to P of x. So I'm thinking about going from the one on the right to the one on the left. So did it move right or left? Left. How many? 7. Up or down?
Down.
How many?
1.
Okay. And the other one's just the opposite of that. So I'm writing M of x in terms of P of x. Right or left? How many? Up or down? How many? Okay. So, going here, last page. Again, all of those, the up, down, left, right, those are considered translations. Okay, where the entire thing moves a certain distance, but the shape is never changed. This right here, this explains those transformations. I'll tell you right now, I don't like the way they explain C. All this is just, and we wrote it down earlier, that plus C goes to the left, minus C goes to the right, plus D goes up, minus D goes left. It's all that. Okay. So if I come down here, if this is my, kind of refer to this, I can take any point on the parabola, and according to what I have highlighted in blue up there, would I add the C value or subtract the C value? Add. Why? Because it's inside the parentheses, and it's inside the parentheses is minus. I would take all of the Y values, and I would do what?
What's under the C?
Comma. Is that what you were talking about? Okay, so now go back to the notes packet that you picked up on the way in. Alright, here's some vocabulary. Now on this, just to make your life easier, if you notice, none of those words are what I would consider small words, but all the spots in the definitions are very small spots. So I would just write A, B, C, and D next to it, and just put A, B, C, and D inside those spots. Okay, that just might make your life a little bit easier. So you've got those definitions, which we talked about, and then you have, I think it's 3 or 4 examples. A few more. We did put another page on there. Okay, of just up, down, left, and right, describing the transformations, and then writing the equations. All right, it is 10 o'clock, and this should not take you very long, especially if you work together on it. Okay, so do that.